Okay, welcome back Year 9. What we're going to do in this video is just have a look at a couple of really key skills that we need in this topic of similarity. And one of those is just a reminder about how to label sides, how to label angles within a shape, how to properly label a triangle, and then how to write a similarity statement. So looking at what symbols we use to show similarity. Okay, so first of all we'll look at labeling sides. Now this is something that you would have done in the past. You would have done it quite a lot. So this is just a little reminder. If I wanted to talk about, say, this side here, instead of, say, putting a symbol on it and calling it something, what I do is I use these letters here that are on either side of that side. So this side here I would call A, B. Now the reason this is really important is if I want to talk about corresponding side on the opposite, on this other triangle, because remember with similarity we're often talking about two shapes. If I want to talk about this same side over here, which is corresponding to that one, I wouldn't call it ED. The reason I wouldn't call it that is because I called this one here AB. So what I need to do is do the order exactly the same. So I need to use the same vertices. So this vertex here, A, corresponds to that one, D. In other words, if I enlarge this triangle and sat it on top of that one, A and D would be sitting identical on top of each other. So this side here I'd actually call DE. Now in similarity, what we do is we set up a ratio like this. And that would be my scale, that could be my scale factor there. Another one that I can do is this side here, BC. Which side does that correspond to? It corresponds to EF. And we know if these are similar, these all must be in the same ratio, shouldn't they? So this fraction here should equal that fraction there. And finally, I can do this one here, the last side, AC, and I would call that DF. So that's how we label sides. We use the two letters, we use the labels of the vertices that are on either end of the side. Moving along, labeling angles. Again, you've done this before, so this is just a little bit of a review. If I wanted to label this angle here, what I would do is use these letters that are given on the triangle. The symbol that we use for angle looks like that. So label this angle, what I do is the A, where the angle is actually situated, that's got to be in the middle. And I use the other two letters I should say, so three of them all together. So start at this end, one end of the angle, then I write the vertex where the angle is situated, and then I write the other remaining vertex. So this one here is angle CAB. I'll use a different colour. This angle here, start over here, ABC, angle ABC is that one there. Now again, just like before, if I wanted to say that two angles were equal, just say I wanted to make a point about, just choose maybe a bright colour, this one here being the same angle as that one there. If they were similar, we know that they would have the same angle. Therefore, I would need to use the vertices in the same order that I had in each triangle. So this one here, I'm going to call this angle ACB. Now, I want to say that it's the same as this angle over here. So I'm not going to say EFD, because that's sort of using the other vertex first, isn't it? If A corresponds to D, A is that same angle as D there, what I'm going to do is say angle DFE. So the same order that I did in this one, ACB angle is the same as angle DFE. So I can say equals, angle symbol again, DFE. So this is the correct notation that you need to be using. Okay, we're up to this one here, labeling a triangle. The symbol we use for triangle is a little triangle, so that makes it easy. This triangle here, what I'm going to do is quite often it's nice to go in alphabetical order, but I'm going to start at the bottom here and work my way around in, well, look, I go anti-clockwise, but triangle ABC is how I would label that one. This one here, triangle symbol, D, E, F, D, E, and F. So you need to show all three vertices and you need to put this little triangle symbol as well. So that triangle there, I would label D, E, F. Hopefully this rings a bell from perhaps congruence if you've done that already. I know that was covered in year 8. Okay, now writing a similarity statement. This will be new. So these symbols here that I've drawn, put a box around them. These are the two symbols that are used for similarity. You don't use both of them, so just pick one of them and stick with it. I usually use this one here. Okay, so what I can see with this triangle here is it's got a right angle, both have a right angle. It's also got a 50-degree angle. Therefore, this angle here must be the same. And what angle would it be? Well, we know they've got to add up to 180. So this is 90 degrees, 50 degrees, 1950 is 140, so that must be 40 degrees in there. We know all three angles are the same, and something neat about triangles is if you've got all three angles the same, they are similar. And that's something that we'll look at in more detail in this topic. So writing a similarity statement, what I want to say is this triangle is similar to that triangle there. First I'm going to write the name of this triangle. It's triangle ABC. Next I'm going to use the similarity symbol. At the moment this says that triangle ABC is similar to triangle. Now, we must match the vertices. If I've said ABC, if I've called this ABC, I cannot say now FED. Why can't I do that? Because A is not the same as F, it's not the same vertex. When I put A first, I must start with the corresponding vertex on this triangle. So A is where the right angle is. So the first vertex I should mention in this triangle is where the right angle is, that's D. The next vertex that I mentioned was B, where the 50 degrees is, and that's E, isn't it? That matches with E. And finally, where the 40 degrees is, that's C, that's the last one I wrote. In this triangle, that is F. So A, B, C is similar to D, E, F. Don't forget your little triangle symbol. What we'll also do in this topic is look at particular reasonings or justification as to how we know that they're similar. Now the reason I know is that all three angles are the same. So we'll get to this in the topic, but basically what I'll write is that in brackets to finish it off. Don't worry too much about that at the moment. We'll get to that in this topic. Last one. Okay, this one's a little bit trickier because as we can see, the triangles are not drawn the same way around, are they? This one's sort of got the longest side facing up that way, whereas this triangle's got the longest side on the opposite. This triangle's actually been reflected to get that one, switched it around. What we do have here is likewise as before, we've got a B, or beta, got this alpha symbol as well. That tells us that these two angles are the same as those two angles. Therefore, this one and that one there must be the same. So just like before, I know all three angles are the same. So therefore, I know they are similar. Let's write a similarity statement then. I'm going to start with this triangle. I'm going to call it DEF. Triangle DEF is similar to, remember your symbol there, the other triangle. Now let's see if we can get this right. Vertex D, whereabouts is vertex D? Where's the corresponding one? Look for what angle's next to it. It's sitting next to the alpha angle. So what vertex is sitting next to the alpha angle here? R. Next I listed E. So which vertex corresponds to E in this triangle? It's S, isn't it? Look where it's positioned in relation to the angle. And finally, I listed vertex F in this triangle. What corresponds to vertex F in this triangle? It's where I've put that pink line, that angle. F and T correspond. So there's our similarity statement. Triangle DEF is similar to triangle RST. The reason? All of the angles are the same. But remember, we'll get to that part in the next couple of videos. Okay, thank you very much for listening in, guys. I apologise, I do have a cold. Hopefully you can hear me. Thanks again.